So, hi to all, my name is Marcel Porta, and today I will present my project Dronecoria. I'm a student of Artificial Intelligence Master Degree in Polytechnic University of Catalonia, and I'm currently in my last year. So, the presentation schedule will be first of all the introduction of the project and the goals, then what has been done during this month, how the work has been structured, and some documentation, especially focused on the machine learning model that is the most difficult part on this project. Then, the demonstration of the web application, the conclusions, personal opinion, and finally will be your turn for ask any question you have. So, first of all, a quick reminder, what is Dronecoria? Dronecoria is a project based in 3 big parts. That is, first of all, a drone will take photos of a possible burnt area. Then, using machine learning, we automatize the process to delimit this burnt area. And finally, we will proceed to do a reforestation of this burnt area because we will know how is the region and we will know the geolocation of this area. So, the project goals. The project goals was, first of all, the user can upload the drone path that the drone will follow to take the first photographs. This path can be visualized on the Liquid Galaxy tool. This goal has been done. Then the user can create galleries of images. These images will be the images corresponding to the burn region, and these images will be displayed on the Liquid Galaxy. Then, using a button, the user can detect this burn region and see this information also in the Liquid Galaxy. And finally, using a button, the user can start with the reforestation of this burn region. So now, what is the work done during this month? During this month, I finished the web application. I started with the machine learning model. I integrate this machine learning model in the web application and test with Liquid Galaxy all the things I'm feeding my project. So, first of all, we have to do a reminder of how a machine learning project is structured. We have these 5 steps, that is, get the data, clean and manipulate the data, train your model, test your data, and improve your model. So, during the second month, I have done the get data step, clean, prepare data, and manipulate data. And during this last month, I will do the train model, testing my model, and improve my model. So, which are the conclusions during the second month? The conclusions was the use of synthetic data, it has been done. Try to obtain a generic model able to support changes in the training data. If in some moment the user wants to train the model with different data that initially, the system has to support these changes. So this is the step that I have to do during this third month. So now, how to develop this machine learning model? You have to think which kind of machine learning model we want. So for example, we want a traditional binary classifier, a system that says yes or no if there is a burnt region. The answer is no. We do not want that. We want something that detects this burnt region here. So maybe image detection. The problem is that the output of image detection is a square of the burnt region. So it is not the approach that we want. The approach that we want is something like this. If you can see here, there is the line that the frontier between the burnt region and the not burnt region. So this is the machine learning model that we want. So how to do that? Which kind of image detection is it? This image detection is known as image semantic segmentation. The system learns which pixels correspond to burnt region and classifies it. For example, we have the image in the left. This image, we have clearly the burnt region here. So, if we segment this image, we can split the image in 2 colors. The black will be the background, and the red will be the burnt region. So, we have to do a research about which kind of implementations of this machine learning model we can use. So I have done a large research between the most important journals and conferences about machine learning, and I have encountered that the state of the art, the most important technology, the best technology in semantic image segmentation is one kind of neural networks named RCNN, Fast Region-Based Convolutional Neural Networks. Traditionally, in image detection, people use neural networks known as CNN. But the problem with this approach is that they tell to you if there is this class, but not where they are located. No, they not tell to you the pixels that correspond to this class. So we need the RCNN approach. The good news to me is that exists an open source implementation of an RCNN neural network, and the name is DeepLab. This implementation is using TensorFlow, so it's perfect for me. So now the challenge will be know how to use, how works the machine learning model DeepLab. DeepLab is a very powerful tool, able to segment a lot of things. So I have to adapt this tool to my approach, that is detect band regions. So DeepLab works in the following way. You have to fit the algorithm with these two kinds of images. This one, that is the original image, and the labeled image. The labeled image will be all the pixels in the original. If you classify it as background, will be in the color black. And if you classify as band region, you will set, for example, this red color to the pixel. So in this way, you label all the pixels of the original image. So administration of the DeepLab is a very powerful tool. There are some examples. This is the input, and this is the output of DeepLab. So DeepLab is able to detect humans, bicycles, then to detect dogs and cats, and to detect horses too. So it's a very powerful tool. So finally, which will be the structure of my machine learning project? My final schema is this. I have to modify GitLab. All the steps to modify this software is documented in the main documentation of the project. And the good point here is that the user only has to interact with the web application, the data folders, and the configuration files. So GitLab and the artificial network will be a kind of black box for the user. He don't need to know how it works, but he can use it and he can train it. So it's a very good approach. So the user only has to create his own dataset, label it correctly, and modify the configuration file. So that's all. And now I will do a demonstration of that is work. So
un suono che dentro la... ¿Y las cámaras dos? Marc? Ivan? Cambiar la cámara, change the camera to the galaxy? Okay.
So I will take for example, the first use case. There are some missions. So for example, the first mission, I send it to the galaxy, and it will be displayed. And yes, this appears the bubble. This is the drone path that the drone will follow to take the first photographs. And then, for example, I can click it. And my second use case, that is here in the application, I have different galleries of images. And for example, I can fly to some forest. So now the band region not appear, but it's in somewhere here. So I will send the band region. Here is the band region, and now the detection. So here appears the longitude and latitude approximately of the band region and the area in hectares. So if I play the reforestation, will appear the drone flying over the band region, and if I stop the orbit, I can clearly, we can see that the drone will follow this path, and this path is exactly the region of the band region. So
you give it applause. You give it applause.
And that's all about my project. So now the conclusions.
The applause was for the drone path. You know that.
Yeah,
and the presentation also has run flawlessly.
It's very difficult to do that.
I brought the mic to the most.
So
the mic to the most.
Yeah. Some conclusions. If we look beyond drone ecoria, beyond this project, I have developed a system that is a generic machine learning model that in image detection, so you can detect anything if you use correctly your trained data, if you label correctly your data. The system is able to detect anything because it's based in the neural network using DeepLab, and DeepLab is a very powerful tool. And the other point is that I geolocalize. If you put the geolocalization of the four corners, I can geolocalize all the pixels of the image. So I can geolocalize and display in a Liquid Galaxy, Google Earth, or any kind of system that support KMLs, this image geolocalizer and the region that you want to predict. So it's interesting. It's an interesting approach. And that's all. Thank you. And if you have any question, you can ask.
Look, you are the mentor of this guy with me. So talk to us from Argentina. Call Argentina.
Hi, okay, congratulations. Maybe I have a lot of questions, but starting for the first one. I'm wondering, like the picture that you use is a perfect polygon. I mean, don't have any errors. This is a real image, or because it looks like this is kind of artificial image or something, because normally born regions are not like this perfect polygon that you design.
The approach has done with artificial data, but at the end of the presentation, when I present my machine learning system, I say that the user can change this data, and the machine learning model will change. And you can use, for example, real data correctly labeled with the schema that I present to you, and the system will predict in real images. And the result will be the same, because I say the same another time. I'm using the neural network that uses DeepLab, and DeepLab is a tool that able to recognize bicycles in a photography. So it's very difficult to recognize bicycles. So if you try with band regions and non-band regions, it will detect correctly your region. More or less, I have answered your question.
Yeah, thank you. Anyway, sometimes a born forest can be a little bit born, a lot of born, so sometimes maybe it's difficult to classify. Maybe it's more easy to classify a bicycle than a born region.
No, the problem is in the labeling. That label a born region is very hard. If you have to label 10,000 of band regions, it's a hard problem to do, because you have to differentiate between very band regions, not too much band regions, and green regions. So this is the problem that you have. But with this classifier, you can do it, because I give to you the tool that you only have to modify the configuration files that are the path of your data folders, the path of your model that you train, and I send to you the scripts to train your model and evaluate your model. So if someone don't know to program, you can use my system. It's the approach that I want to give for the world.
And another question is about the generation of the drone path. I don't know if the drone path is flat or it follows the terrain, and also like the distance between one line to another and the altitude. How do you change these parameters?
Yeah, this is something, well, I geolocalize all the pixels that are in the contour of my band region, and they, not randomly, but with a mathematical function that I programmed, I draw this band region, but not following any kind of altitude or something. I only draw the band region, for example, start with one pixel, go to the pixel in the contour that is in front of it, then move 5 pixels to the left, and then another 10 to the front of, and that's all. So I do not apply any kind of something sophisticated, but it's something that works. And the good point is that I can geolocalize the band region. I detect the band region, and with only the 4 corners of the image, I can geolocalize all the band region. So I think that is a good approach.
And how do you place the image in the liquid galaxy? It's georeferenced, and do you need to place manually?
Yeah, you need to place manually, but if you have an image that is the georeferences is in the metadata or something, maybe future work will be modify this program to add this georeference automatically from your metadata or something. But it's not nothing implemented here. But it's a small change to do in the application. Yeah? Do you follow me?
And what is the, yeah, I follow you, thank you. And as we speak before, normally the pictures taken by drone, they are quite big. How big pictures what is the maximum size of the picture that you can place in the system?
Well, the problem here is that Deep Lab works nice with pictures of not more than 1000 pixels for 1000 pixels. So you have to split your image in small images and process in the Deep Lab schema, in the Deep Lab system, in my system.
Okay, congratulations, thank you so much.
Thank you. Any question? Yes?
Yes, thank you for the presentation. So my question is, how does the input data set look like? How the input, the data set that you're using in the training phase, how does it look like?
Yeah.
I guess it doesn't depend on the shape of the image. So basically, the input data says the most representative value or the significant information is the color information.
Yeah.
So you have different maps basically with different beam shades.
No, what I have is, me lo pots posar a la presentació un segon aquí?
Sí.
I have, the train data is based in 2 images. The same name for each image, and you have the original image and an image with the same cells will, and this image only have, for example, if you have 2 classes, background and band region, only 2 colors. And for example, I will show you now, because it's, yeah. So, for example, here, this is my train data, this image. I process this image to, well, this is the input data, this.
Yeah.
This image and this image with the same name, and as they have the same size, the system knows that pixel 00 is, for example, 100 red, 90 green, and 20 blue. And here, the pixel 00 is 000.
Yeah,
So it's black, it's a background pixel. Yeah, say.
Yeah, okay, so I understand it. The problem is that you train the network to recognize these burned areas, which I see on the left, which is gray, like the gray cloud.
Yeah.
That includes the shape of the form, but you're not really interested in the shape. Because if you show me another picture and I would like to detect that something is burning and it would have a completely different shape, for example, like a square, like
Yeah, but the system.
Yeah.
It's que this something that I was saying
Mike.
is something related of how you know how works neural networks, RCNN. Yeah, so it's something that it's included in the how they trade the data. So really what they are doing is splitting in a kind of matrix, and the shape is something that they learn too. They learn the pixel color, they learn, for example, the histogram of the pixel, of the intensity, and for example, the shape of this
Yes, but to learn the shape, you would need to show the system more pictures. The training set will need to have different.
Yeah, I have a lot of
You
pictures.
have a lot of them.
Yeah. No.
How many do you have?
Well, not too much, but 400. But the good approach is that are image generated by my own with a program, and I can generate at the same time, given a green image, I can put the bar region and generate the label at the same time. So with one click, in 5 minutes, I can generate a dataset of 1,000 images.
Yeah.
But my computer don't support to train a neural network with not too much image. So I use 500.
So
but I use a lot of images with different shapes. Yeah. It's true.
So Jan, for you to know, this project has more difficulties than almost the other projects. It's been a very hard summer for Marcel, believe me. And he has done a very well work. Nice work. The question was that we tried with plenty of people, contacts, public administration. Anything you say, I have contacted them. I have plenty of contacts, and also contacted other people to get images, and it's difficult. Also, we started to get images from some satellites that have some kind of IBA, open IBA, and you can get thick, but this is also difficult. It's not something easy to do.
Yeah.
We have students past year storing images. We have something like 4,000 images, but those were not technical images, were something like for different angles, but those were not valid.
Yeah.
So the approach that Marcel implemented, that he had already explained, is to create this synthetic image. I like the name, synthetic image. It's pretty fantastic. In some time in the future, our colleague you have just to your left will try to help us. And what we're trying is to have the images of some real burns, forest, just like the one in Rivera a few weeks ago. And also, next Saturday we're going to Tenerife and Gran Canaria. So well, we also will try to have the images from the Gran Canaria fire, this amazingly huge fire. So the interesting point is that he has put to work the system with very hard work, because we have no images at all, valid images, so he created this stuff of the synthetic images. But the very important point is that the market is that the system is a black box for anyone that has no knowledge about machine learning. I mean, when we get the images, we put through the images through the web interface, and the machine learning on the real will do the analysis. With the system already is developed, but the system is open for this.
Yeah, and something good is that I have developed the train script, and the user only have to click, and will see that the artificial network is training, and then with another script you can evaluate your artificial network and say, oh, this is not a good result, and search how to improve it. So it's...
Yeah, probably the value proposition will be to have a trained model that detects relatively well this incendious events like this. This will be probably something of high value.
Also, I have to tell you another question is that this is the beginning for every class. Even for him, he's in his first year. You're gonna have
I will do my second year.
He will do his second year master degree. And also we have Gabriel here coming from the University of Barcelona. He's having some kind of pressure because he's coming today from Barcelona, because he is gonna work with us in the next year. He will be working with Marcel and with other students and people on this. So this is a first step. I think it's a very nice step. It's a very nice. The demo also has been very good. Congratulations. And this is only the very first step. So we plan to first obtain images. Without data, you are nothing. You know this because you work at Oracle. You are the one managing down the data of the world. And it's been really hard because we didn't have the images. And without data, you cannot do machine learning. Okay. That's the point. Any other question? Brazil! Doctorado, my beloved doctor from Brazil. Do you have any question for your friend Marcel?
No. I think that he made a great job doing the neural network. We were commenting this with the other mentors right now in the chat. And I think that they answered all the questions.
Good. It's your last opportunity.
No, thank you. I don't have any more questions. I mean, there is a lot of things that we didn't see in the interface, like how to select the image, and I didn't see it from the camera as the interface, but I would like to see it in the documentation.
That's the point. You have only 30 minutes and you have all the code and all the documentation, everyone, because this is open source and everything has been, it will be from Thursday. Thursday will be everything published, updated on the network. So, thank you, Marcel. You can another applause. So we are almost finished with only 10 minutes more.